track stresses. The wheel load, the static load due to the wheel is transmitted to the point of contact of the wheel and the rail. Dynamic effects of wheel load. The dynamic effect is caused due to the speed and the hammer blows by the moving wheels. Hammer blow due to the overall balance of the driving wheel of locomotive. The horizontal thrust due to the nosing actions of the locomotive. The pressure by the flanges of the wheel on the sides of the rail. There is a lateral pressure due to the flange collision with the rail because of locomotive or train moves in a zigzag manner. Stresses due to the irregular in the track when ballast or subgrade are not evenly laid, non-uniformly in the gauge, and top of the rails are not in one level. Additional stresses on curve, lateral bending due to the rigid wheel base of the vehicle and non-uniform distribution of the pressure over outer and the inner wheels. Coning of wheel, the distance between the inside edges of the flange is generally kept lesser than a gauge of the track. So there is a gap between the wheel flanges and running edges of the rail nearly equal to the 1 cm on either side. These are the wheels are cone at slope of 1 in 20. You can see the below figure is cone 1 in 20 everywhere. You can see on both railways track of the side, both sides of the track. The advantages of coning of wheel are to reduce the wear and the tear of the wheel flanges and rails, to provide a possibility a lateral movement of the axle with wheels, to prevent the wheels from slipping to some extent. It provides a smooth ride. It helps the trains to negotiate a curve smoothly. Tilting rails. Rails are tilted inward at an angle of 1 in 20 to reduce wear and tear on the rails as well as a thread of the wheels. As the pressure of the wheel acts near the inner edge of the rail, there is heavy wear and tear of the rails. See, lateral bending stresses are also created due to the eccentric loading of the rail. To reduce the wear and tears as well as the lateral stresses, rails are tilted as a slope of 1 in 20, which is also the slope of the wheel cone. Creep rail. Creep of rail, it is defined as the longitudinal movement of rail with respect to the sleepers in a track. Creep is common to all railway track, but varies in a magnitude considerably. The rail at some places move by several centimeters in a month, while other locations movement rail may be negligible. It is observed that the rails have a tendency to move gradually in a directions of dominant traffic. Indications of creep can be noticed from the following observations: closing of successive expansion spaces in the rail joint in the direction of creep, and opening of the joints at the point from the where the creep starts. Make on the figure and webs of the rails made by the spikes head and screw or the scratching of the rail slide. Causes: wave action, drag theory, starting and accelerating the slowing and stopping train, expansion or contraction of rails, unbalanced traffic, alignment of track, grade of track, type of rails, poor maintenance of track, components and ill design. Remedies: pulling back the rail, provision of anti-creepers by using the steel slippers. Wear on rails. Wear is one of the prominent defects of rails. When the axle load are abnormally heavy and train moves with very fast speed, then concentrated stresses exceeds the elastic limiting, resulting the metal flow on the heads of the rail.